Okay, this is practice 3C, and the first two are asking us to find moles from grams. So we're going to set this up by asking how many moles of arsenic are the equivalent of 50 grams of arsenic, and we need to use the molar mass of arsenic because we're trying to go from grams to moles, and that means we're going to use this part of the conversion, going from grams to moles, from grams to moles. And so we're going to make the conversion look like this, where we're putting moles on the top and molar mass on the bottom. So obviously, let's make that look more like a 5. When we do this, we're going to multiply across the top and divide by the bottom. We're going to take 50, multiply that by 1, and divide that by 75. So we're going to say 50 grams times 1 divided by 75. This is 0.67, we'll say. 0.67 moles of arsenic. Lesson number 2 is set up the identical way. We are trying to find how many moles of lead are in 414 grams of lead. And so we're going to set this up the exact same way as we did the previous example. We're trying to find moles. They have grams, so we're going to go from grams to moles. That means we're going to put 1 mole of lead on the top. 207 grams goes on the bottom. Let's take our calculator. We're going to say 414 times 1. And we're going to multiply that by 1 and divide that by 207. And we get 2 moles of lead. Okay, easy peasy. Numbers 3, 4, and 5 are going to be using the other side of this molar conversion. We're going to go from atoms to moles, or moles to atoms. And notice that in no instance is molar mass required. You don't need to know molar mass. All you need to know for these is that 1 mole is 6.02 times 10 to the 23rd atoms. So, first one is going to ask how many atoms of tungsten, my favorite element, do we have if we have 3 moles of tungsten. So, we're trying to find atoms. They gave us moles. We're going to put moles on the bottom, and we're going to look for atoms on the top. So that's going to put 6.02 times 10 to the 23rd atoms on the top. So we're going to take our calculator. Remember, you want to be entering exponents the right way. So we're going to say 3 moles of tungsten times 6.02. We're going to enter our exponents using second exponent entry, and we're just going to hit 23. And we're going to divide this by 1, which is not necessary. This tells us that we have 1.806 times 10 to the 24th atoms of tungsten. All right, let's do the same thing with nitrogen. This one is asking us to go the other way. In this case, it gives us atoms, and it is asking us to find moles. So how many moles of nitrogen would be the equivalent of 1.204 times 10 to the 24th atoms of nitrogen? And so what we're going to do is we're going to go from atoms to moles. That means moles of nitrogen is going to go on the top. On the bottom, 6.02 times 10 to the 23rd atoms of nitrogen. Remember, you want to be entering your exponents the right way. And so we're going to say 1.204 times 10 to the 24th. We're going to multiply this by 1 and divide this by 6.02 times 10 to the 23rd. This tells us we have 2 moles of nitrogen. That goes right here. Okay, let's do the last one. Go on the other way. How many atoms of potassium are in 3.5 moles? We're going to ask how many atoms of potassium, that's the symbol for potassium, K, if we have 3.5 moles of potassium. So We're going to put moles on the bottom. 1 mole of potassium. Make that look like a K. And 6.02 times 10 to the 23rd atoms of potassium. All right, here we go. We're going to say, let's clear this. 3.5, we're going to multiply across the top, so that's times 6.02 times 10 to the 23rd, and we're going to divide that by 1, which we don't need to do. And we get 2.1 times 10 to the 24th. And that is all you do. See you on the next one.